Welcome to EDU World Space.
So here we're trying to prove the flow speed measured by the venturi meter. So we can use the equation of continuity. The volumetric flow through the second section equals the volumetric flow rate through the first section, or the cross-sectional area of sub 2 times the velocity of the liquid through the second section will be equal to the cross-sectional area of the first section times the velocity through that first section. So we can say that V sub 2 equals A sub 1 V sub 1 divided by A sub 2. And then we can use Bernoulli's equation. So for Bernoulli's equation, we can simply say P sub 1 plus 1/2 of rho V sub 1 squared should equal P sub 2 plus 1/2 rho V sub 2 squared. So here we can then say that 2 times P sub 1 divided by, rather, minus P sub 2 divided by the density equals V sub 2 squared minus V sub 1 squared. We can then substitute V sub 2 here into the Bernoulli's equation and say V sub 1 A sub 1 divided by A sub 2 squared minus V sub 1 squared equals 2 times P sub 1 minus P sub 2 divided by rho, the density. So V sub 1 squared times A sub 1 squared divided by A sub 2 squared minus A sub 2 squared divided by A sub 1 squared. And then this equals 2 times P sub 1 minus P sub 2 divided by rho, the density. And so we can say that V sub 1 squared is going to be equal to 2 times A sub 2 squared times P sub 2, P sub 1 minus P sub 2, and this will be divided by the density times A sub 1 squared minus A sub 2 squared. So this is simple algebraic manipulation. And then we can say that V sub 1 then equals A sub 2 times 2 times P sub 1 minus P sub 2. This will be divided by the density rho times A sub 1 squared minus A sub 2 squared, and then the entire thing will be to the 1/2 power. So that would be the, rather, not to the, my apologies, not to the 1/2 power. No, because we are squaring it here, so this would be squared, so yes, it will be to the 1/2 power. Now this is us proving the flow speed by the venturi meter. So we started with the equation of continuity, solved for V sub 2, plugged it into the Bernoulli's equation, and then got the equation for this flow speed through the venturi meter. And so V sub 1, that would be your answer for part A. For part B, however, they just want you to solve it. So for part B, it'll be V sub 1 equals pi times 1/2 times 0.01 meters quantity squared, and then this will be to the 1/2 power. And this will be 2 times 18 millimeters of mercury times 133 pascals for every millimeter of mercury. And then this will be divided by the density, so 1,000 kilograms per cubic meter times pi squared of 1/2 times 0.03 meters quantity. Well, 1, 2, quantity to the 4th. There we go. And then minus pi squared times 1/2 of 0.01 meters. And this will be to the fourth close parentheses. So that's how you would find the flow speed and the v sub 1 after plugging this into any calculator. This would be equal to 0.24 meters per second. So this would be our final answer for part B. That is the end of the solution. Thank you for watching.